Welcome to the Decoding Innovation podcast series, brought to you by the EY Nottingham Spurk Innovation Hub, where we explore the innovative technologies, business models, and ideas that are shaping the future of industries. During each episode, Mitali Sharma, a principal in the EY Parthenon strategy practice, meets with stakeholders at the cutting edge to discuss innovations in their space, challenges they need to overcome, and their outlook on the future.
Hello and welcome. I'm your host, Mitali Sharma, and today we're talking to Greg Twinney. Greg is the CEO of General Fusion, a nuclear fusion company. Greg, welcome to the show.
Nice to be here. Thanks for inviting me.
Can you give us a background about General Fusion and why the idea that General Fusion is promoting is maybe unique?
Mm-hmm. So General Fusion, we are our mission is to transform the globe's energy source to one that is ultimately going to be delivered via fusion, which is clean, abundant, limitless energy that is not geographically constrained, doesn't have safety issues, it's carbon-free, it's the holy grail of energy. And so our mission is something that when I look at other companies around the world and other opportunities around the world, I can't think of another company that is going to be as disruptive as we will be when we have demonstrated and ultimately commercialized our magnetized target fusion approach to harnessing the power of fusion on Earth.
There's been lots of interest in fusion in the last few years. What attracted you to General Fusion in particular?
So you're right. There has been a lot of interest in fusion recently, and I think that's because of the incredible attributes of fusion. People have been trying to solve fusion since the 1950s, creating machines to replicate the conditions of the sun and the stars here on Earth. And that's a very, very difficult challenge, but recognizing how incredibly powerful fusion will be when commercialized, the pursuit has been going on for many decades, but it's only in the last decade that there's been real advancement around the ability to actually bring this to market. And that's because of mainly additional technologies that bring great ideas to life. So thinking about things like supercomputing power for running models, 3D printing for building machines that previously you couldn't build. These types of things have actually enabled fusion to become a reality. And so why I was attracted to General Fusion in particular is because of the approach, the technology approach. The boxes were ticked in the other areas that when I said how I sort of look at a company that I want to be a part of, and it has to be a huge mission and it has to be very disruptive and big enough that it's worth the time and effort in order to do it. So those boxes are ticked in pretty much any fusion company just because of the industry being so massive. But when I think about the last box, which is, can I help that company? I needed to look at what is the technological approach that is being used for fusion, and does it have a high probability of being successful? And that not just technically and science-wise, but ultimately commercially successful, meaning economics, and in it's sort of delivering to the market in a way that customers could ultimately own and operate the power plants without teams and teams of scientists required. And so General Fusion has a very practical approach to creating fusion and has been at it for 20 years in terms of refining the pieces of the technology that will go into a General Fusion power plant. So maturity of the technology, practicality of the technology, and ultimately having everything required to sort of take that technology out of the lab and bring it to commercial is what sort of attracted me to the company. And it's a very, very unique approach, and also a very entrepreneurial company. When I look at other fusion companies that are out there, a lot of them were started by academia or spin-outs of national labs. And so those are kind of science-driven companies, which fusion, of course, is a huge component. But my belief is that fusion will be solved by an entrepreneur, not by a scientist.
Let's double click on that. So talk to us about the technology and what's unique about it.
Yeah, all right. So if you think about fusion, you're creating the conditions of the sun and stars on Earth, because sun and stars are powered by fusion, and it's really all about taking two light atoms of hydrogen, isotopes of hydrogen, deuterium and tritium, and smashing them together under the right conditions. And when you smash these two atoms together, they fuse and release an extra neutron. And that extra neutron is a huge, huge amount of energy. And it's like 1,000 times the density energy of traditional fission, nuclear fission. So our approach is very unique, and maybe I can just tell you a little bit about how we create fusion in our machine, and then that will give you a little bit of background on why we're so unique and how we tackle these four big challenges. So if you're thinking about how to create the sun on Earth, you want to be inside a machine that is protected. And so what we have done is we've created a large fusion machine that is a large cylinder, a big cavity, where we inject liquid metal inside of it. We spin the liquid metal around, which creates actually a cavity. Inside that liquid metal, we create a plasma, which is ionized hydrogen, about 5 million degrees, and we inject it inside of this liquid metal cavity. And what we do from there is very unique in that we take the liquid metal and we compress down, much like a diesel engine inside of a cylinder compresses air fuel mixture. We're compressing down plasma using liquid metal, which increases the temperature from that 5 million degree initial temperature to 100 million degrees, and also increases the density. And what that does is creates conditions where fusion can happen. So all of that happens in milliseconds, a very brief amount of time, but that energy, the temperature and the neutrons all get released into this liquid metal blanket that compressed it. And that allows for us to protect the machine, allows us to extract the energy, and actually the interaction between the materials we use in the liquid metal and the plasma create tritium. So that allows us to produce fuel, enough fuel, actually more fuel than we even need to sustain the plant indefinitely. So you're creating your own fuel as a byproduct of the overall process. And so what this means is we're able to sort of create fusion using liquid metal compression system, which protects the machine, extracts the heat, and we do all this using existing technologies. The company has been very entrepreneurial from the start, and in the approach that everything we do needs to be focused on a commercial power plant, and it needs to use existing technologies to do it. That reduces the overall risk on the path to commercializing. Long explanation. Fusion is a complicated topic. However, hopefully that gives you a bit of background.
The other thing that also is a big issue, particularly for nuclear fusion, is net positive energy. How far are you guys from that?
The end in mind that we are focused on is a commercial power plant that ultimately can put power on the grid. So you need to start with that in mind and think about the entire process of creating electricity inside of your power plant. And we used this sort of pulsed approach. So I talked about liquid metal squeezing plasma, releasing the energy. And the way that we are doing the compression and that we're pulsing this is using steam-driven pistons. And what that means is that we need a lot less energy coming back into the process. There's a lot more efficiency in the process because ultimately what we're doing is we're taking this hot liquid metal, we're turning that into through a heat exchanger and creating steam. We're recirculating steam back through our system to continue to create fusion. We know exactly how much energy we will get out of our plasma when we compress it at large scale, and have calculated using simulations, not just our own, to ensure that when we are demonstrating our technology at large scale, we'll be producing net positive conditions for a net positive ultimately plant. The challenge with fusion is that fusion works bigger, better. And why that is because you're talking about plasmas that are in the 100 million degree temperature range, and that cools down extremely fast, as you can imagine. And so a larger amount of plasma cools down slower than a very, very small amount of plasma. And so that's why you see a lot of the machines being massive machines, because having more plasma allows you to keep it at those temperatures necessary for fusion. And so for us, we have demonstrated fusion at small scale, but because we're using a pulsed approach, we will need to pulse it on a regular basis in a machine before we're able to actually demonstrate the net positive that we know we'll get based on our simulations.
Greg, net positive energy generation has always been hard, particularly for fusion. How's General Fusion tackling that problem?
Great question. And always a big debate in fusion world as to sort of net positive energy. And I would say that this is where an entrepreneurial mindset with an end in mind for a commercial power plant comes into play for us. Our goal is a net positive energy onto the grid. And so with that end in mind, we designed a power plant and ultimately a fusion machine that's inside that power plant that will result in net positive energy onto the grid. So you start with that, you work your way back through the various systems that need to be developed to create this power plant. And we, for the last 20 years, have been working on large-scale prototypes, which are the major components of a ultimately fusion power plant using our approach, and have achieved a level of confidence in the system level. So these large-scale plasma injectors, large-scale compression systems, these types of things, that we are now going to put them all together and prove that when you do produce fusion at this scale, you get the results of the simulations, and that ultimately end in mind of net positive is demonstrated at scale.
That's very exciting. How far do you think you are from that point?
Yeah, so we are putting a shovel in the ground for a power plant relevant sized demonstration of this technology in the beginning of 2023. It's a massive, massive milestone for the company. Despite having proven at large scale that each of these systems produce the results that we want, it isn't until we put them all together that we'll get the true credit for all of the IP and all of the expertise and everything, all the technology that we've built over the last couple of decades. We'll get all that value when we're demonstrating at large scale. So it's a very exciting time for us. We will be the most, I'd say that the largest, most power plant relevant demonstration of fusion in the world.
As you think about your journey, Greg, and you think about the commercialization angle that you've taken, was it the technology that was driving the way you thought about how you wanted to commercialize it? Or the commercialization was front and center when the team started to think about how to solve the problem?
Front and center was commercialization, and that was the goal. And I think that is the major differentiator between us and most of the other companies or groups trying to achieve fusion, is that our founder started this company 20 years ago with the end in mind to build a practical, sustainable source of fusion that could ultimately disrupt the world and solve this climate challenge that we've got. And so the end in mind was a commercial power plant at scale. And then it was his pursuit was finding a technology that could solve that. So it started with an end in mind to build power plants that could ultimately be commercialized in a time frame that mattered. And second was finding a technology that would fit that need.
Greg, this has been a fascinating conversation. Thank you so much for your time today, and good luck with everything we'll be watching.
Thank you for having me.
On December 13th, 2022, U.S. Department of Energy and National Nuclear Security Administration announced the achievement of fusion ignition at Lawrence Livermore National Lab. This podcast episode was recorded prior to that announcement.
The Decoding Innovation podcast series is a limited production of the EY Nottingham Spurk Innovation Hub, based in Cleveland, Ohio. For more information, visit our website at ey.com/decodinginnovation. If you enjoyed this podcast, please subscribe, leave a review wherever you get your podcasts, and be sure to spread the word.